Look at the two graphs in front of you, the red one and the blue one. While they may seem different, they actually are obtained by stretching one of them vertically. Now, let me explain how that works so there is no confusion. First, look at the original one, the red one, which is absolute value of x, and hopefully you can recognize that that is the familiar V shape. And the new one is 3 multiplied by absolute value of x. Okay, the easiest thing to do, first of all, is to look for what happens to the point 1, 1. Let's get closer and take a look. The original graph at 1, 1 was right here, right? Now, what happened to the new graph if you stretch it? This green point will become this point right here. Remember, you are vertically stretching it, which means that you are not going to move left or right. You're just moving up. You see? So the original point has coordinates 1, 1. The new point has coordinates 1, 3. What happened? The y value got multiplied by 3. And that's going to happen for every single point. For example, if you look at this one, this is 0.5, 0.5, right? What happened to that point? Well, you moved over here, and now it became the same x value, but the y value got multiplied by 3. And that happens for every single point. That's how vertical stretches work. Except there is one point, if you look at it, right here, which is called the vertex, 0, 0. That did not move. Why? Because when you multiply 0 by, let's say, 3, that is not going to change. So 0, 0 really stayed the same. All right, and so in here, to graph a vertical stretch of absolute value of x, we select, hopefully you understand, this is x squared, this is square root of x, and then this is the absolute value of x. The vertex stays the same. The point 1, 1 should move and become 1, 3. That's your graph. And then over here, of course, we're just going to multiply by 3. By the way, how did we know that this was a vertical stretch and not a compression? All you have to do is look at the number and see if the number is higher than 1. If it is, then it's going to be a stretch. But if it's something like in this example where it's 1/4 and it's less than 1, that's going to be the compression. Now, I want you to look at the two graphs. The absolute value of x is the red graph, and then 1/4 of it is the blue graph. What happened? Now, it's easier actually in this case because we're dividing by a factor of 4 or multiplying by 1/4, is to look at what happens to the 0.44. If you look over here, the 0.44 where it was now becomes 4,1. So what happened? The x value stays the same, but the y value got shrunk, right, by a factor of 1/4. 4, if you multiply it by 1/4, that gives you 1. And that happens for every single point. Like, for example, if you were over here, the new point, again, will going to shrink, and the y value instead of 2 is going to be 0.5. So again, what happens is the y value changes by that factor, the x value doesn't change. Okay, so right here, we're just going to say, okay, this is 1/4 of absolute value of x. Again, to graph it, we select absolute value, which is the V shape. 0, 0 stays the same. And the 0.44 will become 4,1 because it's going to shrink.